today now we'll be discussing about we have already discussed the decision making under uncertainty. Now we'll be discussing about the decision making under risk. Right. So we have discussed certain methods under uncertainty. We now will be discussing certain methods under risk. So this is how it goes. This is the last unit of your MBA syllabus, I would say, right? And so we'll be discussing about the decision making under risk. Decision making when there are several possible states of nature, and we know the probabilities associated with each possible state. Most popular method is to choose the alternative with the highest expected monetary value, right? How do we calculate the expected monetary value? Will be taking care of that as well, right? So the probability, the expected monetary value is calculated using this formula. Payoff of first state of nature into my probability of first state of nature, right? Plus my payoff of the second state of nature into my probability of second state of nature, plus my payoff of last state of nature into my probability of last state of nature. So we have already discussed the Thomson Lumber Company, right? We have calculated under uncertainty. We have calculated five methods. We have calculated what decision could be taken under those five under methods, right? So now we'll be calculating the EMV value, that is the expected monetary value for the Thomson and Lumber, right? So each there are two states of nature in that Thomson and Lumber. We have already discussed in the previous lectures, previous videos, right? The first one is favorable and the second one is unfavorable market, right? So here it is given that each market has a probability of zero point 0.5, right? Which alternative would give the highest EMV? The calculations are as per, like three alternatives were there: large plant, small plant, and do nothing, right? In the large plant, when it was a favorable market, the revenue was 2 lakh dollars, and then when it was unfavorable market, the revenue was minus 1,80,000 dollars, right? So the MV is coming out to be $10,000 in the first alternative, which is the my large plant. And in case of small plant, the expected monetary value is coming out to be $40,000, which is zero point 0.5 into 1 lakh plus my zero point 0.5 into minus 20,000, right? And when you do nothing, that means you don't set up a plant for expanding your manufacturing base, you obviously the revenue will be zero, right? So the expected market value in small plant is more than the expected market value in large plant. So this is the answer of this largest EMV, right? So the largest EMV is for a construct a small plant, right? So expected value of perfect information. Now there is another criterion in under risk, under decision making under risk, which is expected value of perfect information, right? Scientific marketing Inc. offers analysis that will prove certainty about market conditions favorable. Additional information will cost $65,000. Is it worth purchasing the information? Right. So there is a company, Scientific Marketing Inc., which offers an analysis on the favorable conditions if the market is favorable, right? And they are charging 65,000 additional dollars, $65,000 of additional cost for that analysis, right? So we wanted to know that is it worth purchasing the information? So for that purpose, we need to find out the expected value of perfect information, right? So how do we need to find out the expected value of perfect information? So first, the method is here, right? How do we calculate? EVPI places an upper bound on what you should pay for additional information. EVPI is equal to EVWPI minus maximum EMV, expected market value, right? Monetary value, sorry, right? Which we have calculated in the previous slides. So EVWPI is the long run average return if we have perfect information before a decision is made, right? So this is a phenomenon which was of long run average return, right? So the formula for calculating EVWPI is best payoff for the first state of nature, right? Best payoff means that the maximum one, into my probability of first state of nature plus my best pair for the second state of nature into my probability of second state of nature. Likewise in case of EMV, right? So this is how we calculate EVWPI, right? So the best alternative for favorable state of nature in is build a large plant with a payoff of 2 lakh dollars. Best alternative for unfavorable state of nature is to do nothing with a payoff of zero, right? So how do we calculate EVWPI, which is 2 lakh into my zero point 0.5 into my 0 into my zero point 0.5, which is coming out to be 1. So the maximum EMV which we calculated using the formula which we have discussed in the previous slides was 40,000, was coming out to be 40,000. So therefore EVPA will be 1 lakh minus 40,000, which is 60,000, right? So the EVPA is expected value of perfect information. That means if there is a perfect information about certain things, so we can have we can have a value of $60,000 in our case. So the maximum Thomson should pay for the additional information is 60,000, but they were charging to $65,000. So and they should negotiate to 60,000. This is the maximum amount, right? If not, they should not they should not give their information there. They should not ask that company to do the analysis of the market, right? So this is how we do a perfect market analysis, right? So these were the two criterions or methods, I would say, for finding out the decision making under certainty, right? So this one is a pretty different method, I would say, which is based on decision trees, right? So what are primarily decision trees? They are graphical display of decision process, that is alternatives, state of nature, probabilities, and payoffs. Decision tables are convenient for problems with one set of alternatives and states of nature. So they are more suitable, they are more convenient for problems having one set of alternatives and states of nature. Right? For example, in our case, we have different sets of alternatives and different states of nature. Right? With several sets of alternatives and states of nature, sequential decision trees are used. So when we have different sets of alternatives, like in our case, it was three: to build a big plant, to build a small plant, and to do nothing, right? And we have two states of nature. That is favorable market and the unfavorable market, right? In this case, decision trees can be more useful than the other methods which we have discussed in the previous lectures and previous slides. EMV criterion is the most commonly used criterion in decision tree analysis, right? In decision tree analysis, we calculate the expected monetary value. Based on that, we take the decision. Softwares, there are certain softwares which can be used for doing the decision tree analysis. The first one is DPL, Tree Plan, Super Tree, right? These are some of the softwares. You'll find some more on Google. You can do Google for finding out the different softwares that are used for decision tree analysis. Analysis is done with little effort, full color presentations for managers. So these softwares provide analysis with less effort. You can make a decision tree using less effort, and the colors will be very bright and will be very beautiful for presentation to the managers. That's why we use these kind of softwares for making a decision tree analysis. Steps of decision tree analysis: define the problem, structure or draw the decision tree, assign probabilities to the states of nature, right? Assigning the probabilities is the most important task because decision making under uncertainty or risk, I would say, is based on this phenomenon that probabilities are assigned to different states of nature, so that we can find it out that whether which alternative is the best one, right? So assigning the probabilities is always very crucial step in making a decision through decision tree analysis, right? The fourth one is estimate payoffs for each possible combination of alternatives and states of nature. Solve the problem by computing expected monetary values for each state of nature node. Okay, so this is how a decision tree analysis look like. Right, this is the square represents a decision node, and that with after calculating all the states of nature, after calculating all the probabilities, after calculating all the alternative outcomes, so we'll write the decision node. We'll write the decision on the decision node. So it is represented by a square. Right. There are two alternatives: alternative one and alternative two. Alternative one, in our case, this is just a graphical representation of how a decision tree look like right. So the state one is there, state two is there. If there is state one and you are choosing the alternative one, the outcome one will come. If you are choosing the state two of the alternative one, outcome two will come, right? And if you are choosing state one of alternative two, outcome three will come. And if you are choosing state two of alternative two, your outcome four will come. Then based on these four outcomes, we will select the best one and we'll write the decision on the decision node, right? So in our case, in this case, we are taking an example of Get's products decision tree, right? Similar to that of which we have discussed in the Thomson number case, right? So it's the name is different, but yes, uh, the outcome or the example is same, right? So we are solving this using a decision tree. So calculating EMB for alternative one and calculating EMB for node two, right? So in our case, EMB for node two is coming out to be 40,000. So we'll be constructing a small plant. Obviously, we have calculated EMB. We have discussed the formula for calculating the EMB, right? So we just what we do is we do it using a decision tree, right? So that it can be made more useful to the managers, right? So I mean it represents more appealing to the managers. It has a more much effect than other methods. It's a graphical representation of what we have done in EMB model, EMB criterion, right? Expected monetary value, right? The formula is same similarly for this market as well. This example as well, where we have two market states, favorable market and unfavorable market, and the probabilities assigned is zero point 0.5 and zero point 0.5 for constructing a large plant. If you are doing nothing, then there will be no market. I mean, you'll be getting a zero. That's why I haven't written favorable market or unfavorable market. But in case of construct a small plant, right? Again, there are two alternatives, that is favorable market and unfavorable market, right? So you will be calculating the EMB value for that as well, right? The highest EMB value is selected, obviously, right? And for which it is of node 2, so we are selecting node 2 and construct a small plant as one of the alternatives or the best decisions to be taken.